Come all you moonshiners if you want to hear about the kind
Yep,
of
today's the
blues
day
that's
you
brewed
caught me out
around
at the
here.
shop. I'm
Made
doing
way
some
back
testing, I'm
in
doing some
Crawfordville,
research, and this is all
pretty
about
sharp
temperature.
moonshine still.
We track temperature in our
Well, don't
systems
give your
for a
barn first
particular
smoke,
reason,
Fred
because
Wall, and your
for two
propane
reasons really.
and
One, we
your
want to
scarecrow.
know, and
Made out of
two,
buckeye
we know what
flame,
happens at
pour a
certain
candle
temperatures.
bottle.
But we've got to be able to get a reading to find out what those temperatures are. I've got some options for you, and I've got some ideas. Let's get right to it. Have that feedback indicator of what is the temperature so that you can manipulate the control. Now, that may be in a still, it may be in a bakelite oven, it may be in any other process, but of course, in all of those processes, we need some sort of a feedback mechanism. Well, a real simple solution to that would be to use one of these devices that I've already demonstrated, or I found these on Amazon. Amazon's not the only place you can get them. This is a small digital temperature readout with a K-type thermal probe. And they're really, really unique because they are universal. I love off-the-shelf products. Yeah, and please just ignore the board behind me. I'm working on something else at the same time. We're not going to use that today. These things will fit just about anywhere, and you could fashion it into your box by moving this up and just placing it under here, so you've got a place to mount your. And oh, by the way, we always put a fan inside your box just for the circulation. Can you get away without it? Yeah, probably, but it's better to have and not need. Yep, than to need and not have. So keep that in mind. Plus, if you do that, you can always wire these in directly to the same power source you have for the fan. Go figure. What I want to show you, though, is I want to show you some of the different options that you have and how these actually work. They're really, really unique. They have, this one comes, these operate on 4 to 28 volts of direct current. So what does that tell us? Well, that means that we have several different options for a power source. We don't want to put 120 volts of alternating current, AC, into this. It's got to be DC voltage at anywhere between 4 and 28 volts. Well, that's wonderful. I measured this as it was operating, and it only draws 0.002 amps. That's 2 milliamps. So that's really, 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 really low on the scale in comparison to some of the other devices that you have. Now, why is that important? 'Cause remember, we've talked about this before. What controls the amperage or the current through your circuit? Yes, the requirement of the load. And in this particular case, this small load only requires a very small amount of current in order to operate. So that comes in handy. That's a good piece of information to know. We'll get to that. Some of the options that you have, since these things work on 4 to 28 volts, is the first one is a 9-volt battery. If you just place, and here, I'll touch these to the end of the 9-volt batteries. There's the red goes on positive, and the black one goes on the negative. And I got to do this with 2 hands, and at the same time show you this readout. There we go, voila, and she's working. So it'll work on a 9-volt battery. The only drawback to that, potentially, is where do you place the battery and how do you change it out and you turn it off when you're not using it. Oh yeah, you could put a switch in here, put a small switch. You could do a whole bunch of things. You could just have one of those, you have so many options. So there's a 9-volt battery makes it work. I also have, oh, by the way, these temperature probes, K-type temperature probes. The question comes up a lot of times, do I need a K-type or do I need a PT100? Well, the PT100 probe has 3 wires on it, so it wires up a little bit differently. Not too challenging, very straightforward. And the K-type probe only has 2. They both do exactly the same thing. If you were measuring somewhere in the neighborhood of, I don't know, maybe 400 or 500 degrees Celsius, you might want to use a PT100. But other than that, a K-type probe is more than adequate for what we do. Okay, and they come in many different styles. Just type in your Google search bar, in Amazon, on eBay, on any of those places, just type in K-type thermoprobe or thermocouple or temperature probe. And these things will start to pop up. They're relatively inexpensive, and I use that term lightly because relatively inexpensive, it all depends on where you find them. They can be as little as $3 or $4, or if you're willing to pay it, as much as 20 bucks. It's up to you. This one has got the 50 millimeter probe. I've got one here with a 100 millimeter probe. What's the difference? What physical environment does it fit in? That's the only difference. They both do exactly the same thing. I've got another one here that would fit most of our community stills if they have that cap with a 1/2 inch NPT threaded fitting. It comes with a 1/2 inch NPT base. Those are available too. Just type that in. Okay, so any of these would work on one of these. All you have to do is just remove these 2 screws or loosen these 2 screws, remove the wires, and place the wires back on the same way. Okay? And remember that a K-type probe is polarity specific. And what I mean by that is the positive goes on the positive screw, the negative on the negative screw. And I know, and it happens. What happens if you wire it backwards? Well, it reads backwards. So when the temperature is going up, you've got the heat turned on, your numbers are starting to go down. And you're like, what the? It's working backwards. Well, just undo these screws and switch those leads, and then it'll read in the proper direction. Okay, one of the other options you have is, and I've got one of these, gosh, these come in so many different sizes, styles, varieties. I've got a small AC transformer. It transforms AC to DC. And this one is a 12 volt, 1.25 amp. Remember that? This only draws 0.002 amps. Oh, so this will handle it. This will handle multiple of these relatively easy. And so what I've done is I've wired, and you can see that I'll put a plug on the end of 2 wires. It has a neutral and a load side. So your hot wire goes to the load. Your neutral, normally the white wire, goes to the neutral side, and you have a grounding lug as well. And on this side, it has V positive, V negative. That's voltage. That's the red one goes to the positive, and the black one goes to the negative. And there's also a small place in here for the adjust. For those who are in the advanced stages of I just got to play with something, we're out there. If you turn this on and you start to adjust that screw, what you're doing is you're adjusting the output voltage of the device. If you really want to mess with it. It's not necessary for our purposes. It's rated at 12 volts, 1.25 amps. Just let it be. If we plug this in, this works the same way as our 12 volt battery. And you'll notice that comes on. There's a small green light here that tells you the unit's operating. So that's the usefulness of that. Oh, see, so many options available to you. Here's one other that I know that you've got laying around. These small cubes that you use for cell phone chargers? Or you may have just a large cube, a large square for a cell phone charger that plugs into the wall. These things work extremely well because most cell phone chargers are rated at 5 volts at 50 milliamps. That's what this is rated for. And you can read it right on the bottom of the thing. 5 volts. Well, these things operate between 4 and 28 volts. So do we have enough voltage? Yes. Will it handle the amperage? Well, yeah, it'll handle 50 milliamps, but we only need 2. So this is only going to draw 2 milliamps through this, but perfectly safe. So I know you've got one of these laying around in that drawer of stuff that you keep collecting, and USB cables. Now, USB cables are abundant. You can get them at any dollar store. You can get them just about anywhere. 7-Eleven's got them. A USB cable, the standard USB, this is a Type A. They come in Type A, Type B, Type C. They come in minis. They come in micros. Just use the same one that goes in the end of your cube. And in most cases, it'll be a standard Type A USB. And then on the other end, you've got either a micro or a mini. All we need to do is cut that off. Because here's where this comes in. See, these are things that you've got laying around that just work. And if we strip back that insulation, you'll notice in a USB cable, this is the type A, we have 4 wires. We have a red, we have a black, we have a white, and we have a green. Well, go figure. The red and the black are pretty obvious. We know that is the positive, red, and black is the negative. We don't need these other two because these are data cables. So I just cut them off. You don't have to, but I just cut them off. Now, oh yeah, here comes the fun part. The only thing left to do is to marry these two black wires together and these 2 red wires together, and you end up with something that looks like this. And I use that heat shrink tape. You know, you put them on there and use a heat gun, and so it seals it, and it just makes it nice and clean. This you plug into the end of your USB cell phone charger. Plug that into the socket, and lo and behold, we are now working just like we normally would with either the 9-volt battery, wherever that's at. Yeah, there we go. We got a 9-volt battery option. We got a 12-volt transformer option. There are many, many options. And now we've got the cell phone charger option. Now here's a tip for you. If you use the 40 millimeter fan that's rated at 5 volts, keep that in mind. It's rated at 5 volts. And then you have one of these, which is rated at 4 to 28 volts. And you put one of these cubes inside this box, you can run both the fan and the temperature probe at the same time. It's that simple and that direct. You can run that fan and a couple of these at the same time. So see, they can all be wired into the same circuit, and you can put those all on the same switch so that when you push the button and switch the hot lead, if you put a switch somewhere in here, well then every time you turn the switch on, this will come on, your fan will come on, and everything seems to be working. So there you have it. Your options for battery control, cell phone charger control, transformer control. You've got the options available to you to design and build your own. I've seen people who have had boxes like this with 4 or 5 of them on there. And they're taking temperature readings from different places within their system so they can do some calculations and correlations between what's kind of going on. It's kind of neat, and it is really, really simple. I needed to share that with you. Oh, until next time. Yep, happy distilling.